So here we go. Today, we are covering chapter 7 notes. Make sure you get the chapter 7 notes. Today, we're going to cover 7.1, 7.4 on confidence intervals. Pretty much everybody loves confidence intervals. They're pretty straightforward. They're pretty easy to grasp in general. The trick is that it's really important that even though they're easy to grasp, that you make sure you really get them down super, super clearly, super, super well, because when we start chapter 8 next week, people mix them up a lot. They get confused between the two. So make sure you really get a good handle on chapter 7, so that when you get to chapter 8, you can keep them straight, between the two. Okay. Today we have due lab 7 is late for full credit today, so you can turn in late today for full credit.
Lab 7?
Lab 4, sorry. My bad, lab 4, I can't talk apparently. After today, if you turn it in after that, you'll lose 10% for each week that it's late. So that's how all the labs work. So you've got old labs to turn in, you can turn them in late for full credit. Not for full credit, late for reduced credit. So feel free to do that. On Thursday, lab 5 is officially due on Thursday, so try to get it done Thursday because next week we have this floodgate of things being due on Connect Math. You have nothing due this week on Connect Math. So now's the time to kind of knock your labs out, get those taken care of. Feel free to come in between 4:15 and 5 o'clock. You can pop into that room anytime you want and work on the labs. So, you can come in at 4 if you wanted to and start in on that. And then between 4:15 and 5:15, me and the tutors are always here just doing nothing, just chatting. So we're always happy to help with Excel lab questions. Good. Monday, we're going to have the 7.1, 7.4 Connect Math due on Monday. And then Tuesday, right away, you have another one due, the 7.3 Connect Math. Will be due on Tuesday. So the thing is that technically, I should have made this one due on Sunday, but I thought that maybe folks might want one more day in case you have questions. You could bring them on Monday and ask them before it was due Monday night. So that's why I bumped it to Monday. So then you have Monday and Tuesday right next to each other, which I don't like to have, but I felt like, like I said, you might have questions you wanted to have answered in class on Monday. And then Thursday, Connect Math 8.1, 8.4 is due. So your first Connect Math for chapter 8. Okay, and also Excel Lab 7. And so that kind of takes care of all the Excel labs. That'll be your last Excel lab. Excel Lab 7 will be the end of it. And then you'll have no more labs the rest of the semester. All right, good deal. Exam 2. All right, it's only worth 12% of your grade. So if you did not do well, it's not the end of the world. But you really need to step up for Exam 3. Exam 3 relies quite a fair amount and builds off of Chapter 6. So it's important to kind of at least have some of the basics of Chapter 6 down before you hop into, before you can really wrap your heads around 7, 8, 9. So ask questions in class, right? And the key about that too is ask the question right away when you're like, wait, this is confusing for me. Ask it right away because it might take me 30 seconds just to get you all on your way, and there might be other people who are having that same issue. And then you'll be like, oh, I got it, and then you'll move on, and then everything else I say for the next 5 minutes will make sense, as opposed to you sitting there for 5 minutes saying, wait, what was that? And then missing and not understanding the next 5 minutes. You know what I mean? So right away when you have a question about it, ask it right away. Even if you have to wave and throw something at me, nothing hard or sharp, but get my attention. And then we can make sure that everyone's kind of on board as we go through. Also ask others for help to understand, not what to do. So just be like, what's my next step? Don't just copy down or rotely try to follow what they're doing. Make sure you understand what people are saying or explaining, and vice versa. If you're explaining to somebody else, don't just say, oh, just do this, then do this, then do that. Make sure that the folks understand what to do so that they can do it on their own, right? That's the whole idea. And then remember, the in-class labs and quizzes are often similar to exam questions. So if you're struggling with the exam questions, but it's making sense in class, then maybe make sure that in class that you're being independent. Does that make sense? So maybe if you felt like the last exam was really confusing, then maybe try to do a little bit more on your own, and then just when you struggle, ask questions. Does that sort of make sense? A little bit more, so that you're not dependent on your classmates so much. On the other hand, if you don't understand it, then you got to ask them for help. So again, when you ask for help, try to do it with a sense of understanding, not just what to do next. You can also go to the tutoring center for their drop-in hours. It's super helpful. When you do your homework, there's Connect Math has all these textbook videos that are super helpful to watch as well. So make use of those. Those are free, right? Well, not free. You paid for them. So now you paid for them. You might as well get your money's worth, right? And then do the study guide. Make sure you do the study guide before each exam, and do the questions first, and then check your answers. So that's kind of the way to do it. Don't be looking at the answers first, because then they'll just sort of, you'll think you know how to do it, and really when you get on your own, it's just that much harder. And then don't forget, it's also very common for people to take Math 40 twice. Right? So the first time is sort of just getting to know the terms and getting a kind of a rough idea and sort of setting a base layer, and then the second time, really absorbing it and passing it that class. So that's super common. Okay. Oh, and part of that being super common is make sure that you don't give up. So I don't think it's been in here, but if you are planning on withdrawing this class, stay at least through up to through chapter 9, because you want to make sure you get a really good look at chapter 9, 7, 8, 9, because that's super new and different material. Okay. All right. So chapter 7, this chapter that everybody loves. Why do we take a sample? Why do we take a sample? Anybody? Because, for example, polls, right? Trump has a 41% approval rating. Why did someone bother taking a poll about Trump's approval rating last year or a couple years ago? Yes?
We take samples to predict things?
Yeah, to predict things. In this case, what are we trying to predict? We take a poll, 41% was my poll, so what am I trying to predict? That 41% predicts
That 41% of people will vote.
what everybody in the whole country thinks. Does that make sense? Why don't I just ask everybody in the whole country?
Money?
That's impossible. It's expensive, right, to ask every single person. Right? It's called an election, so we only do it, every 4 years because it's expensive. It takes a lot, So we take a sample. We want to know something about a whole population, but it's too hard to ask the entire population. Right? So then we ask this smaller sample. What does the proportion look like? Where does it come from? What kind of question does it come from? So say I ask this question. How tall are you? Okay, great. A little louder. How tall are you? 5'7". How tall are you? 5'4". What kind of answers are these?
Numerical?
They're numerical. They're numbers, right? Height. So that is a mean type question. Those answers will give me a mean. Is everyone kind of following? Yeah. All right. So instead, what if I said, do you have a dog? Say it louder.
No.
Do you have a dog?
Yes.
Do you have a dog?
Yes.
Do you have a dog?
No.
All right. So what kind of question? What kind of answers are those?
Categorical?
No.
Yes, but even more specific than that. Yes, they're categorical, but even more specifically, they're what type of categorical?
Binomial?
Binomial. Yes, no questions, right? Only two possible answers. So proportion is very strongly related to binomials. Yes, no's. Either you are or you aren't. All right, so when we have a question that is a yes-no question, we're looking at proportions. When you're having a question that you ask of the subjects that's a numerical answer, that's when you're looking at a mean. So we're going to have two types of problems. Chapter 7, 8, and 9, we're going to have proportions, and we're going to have means. Proportions are going to come from the yes-no questions. Means are going to come from the numerical answer questions. Right? Like height, distance, I don't know, years, time, things like that, right? All right, so this is the first blank that you're filling in on your sheet. A point estimate. So when you graph a point on the number line, what is that? when you have a number line. You graph the point. I graph the point 4. Is it going to be just this point, or is it going to be this whole thing here? What is it?
Oh,
It's just a dot, right? It's just this one dot here. So a point estimate means just one number, one spot, one number that is my best approximation of whatever it is, but the population mean or the population proportion. So it's just one number that's your best guess. Why am I reading this? Rachel, go read.
The sample proportion
P hat. So everyone look at the little symbol over the P. That's a P hat. Like the P's wearing a hat, just like this, right? P hat. Go ahead.
The sample proportion P hat is the best point estimate of the population proportion.
P naught. Who's ever heard of all is for naught? The English phrase? Tell people, that's the English phrase N-A-U-G-H-T. It means all is for nothing. So naught means nothing or zero. P sub zero, P naught. Keep going.
The sample mean X bar is the best point estimate of the population mean.
Yep, population mean mu. So you darn well better know X bar and mu at this point or else it's big trouble for you. But now we're throwing in P hat, sample proportion, and P naught, population proportion. So my best guess at what the whole country thinks, if my P hat, if my sample proportion was 41% approve of Trump, my best guess of the whole country, P naught is also 41%. Right? If my sample had an average height of 5'4.3", then my best guess of the population height is 5'4.3", right? Whatever you get from your sample is what you get, is your best guess for the whole population. All right. Noor, go ahead and read for me.
The Pew Research Center conducted a survey of 1,007 adults and found that 85% of them know what bigger is. The best point estimate of P, the population proportion, is the sample proportion.
Right. What's that symbol called?
P
P hat? P hat equals 0.85. So in other words, if my sample says that 85% for my sample, 85% of them knew what Twitter was, my best guess of the whole country is 85%. Make sense? Very good. Okay. Lindsay, go ahead and read for me.
Confidence interval. Statistic plus or minus the z-value multiplied by the standard deviation of the statistic.
Great. So what this is the statistics. So, so for example, your p hat, your sample proportion. Sorry, I'm having trouble with this. Sample proportion plus or minus your z-value. So some z-score multiplied by whatever standard deviation is. Right? Because remember, your z-score tells you how many standard deviations you want to go, and you multiply that by standard deviation. We've done that before a few times. Remember when we said using the range rule of thumb to estimate the lowest usual value and the highest usual value? Everybody remember doing that? Mm-hmm. What do? We took our number and then we added two standard deviations. We added two standard deviations and we subtracted two standard deviations. So in that case, that was our x bar plus 2. We used 2 for our z value, multiplied by whatever our standard deviation is. This is the same thing. This is exactly the same thing. We're going to start using the proportions first. So let's get Omar.
The confidence level is the probability, 1 minus A.
Alpha. Oh, that's alpha.
Alpha. That the interval estimate will contain the parameter, assuming that a large number of samples are selected and that the estimation process on the same parameter is repeated.
Perfect. Right. So estimate is the word you should be filling into your sheet, right? The confidence interval or interval estimate is a range of values used to estimate the true value of a population parameter. Confidence interval is sometimes abbreviated as CI. I'll do that a lot. I'll call it confidence interval, CI. We also have to be careful about interpreting them correctly. So, did I not do the, maybe I haven't yet. So, in other words, we don't say there's a 95% chance that it's within this range. What it really is a 95% chance that this range contains the actual proportion of the actual mean. So let me back it up a little bit. So let me ask you this. Did I not do that already? I guess I didn't. So question to all of you. I'm supposed to do that here. Okay. Question to all of you is this. How long, let me get you a sheet that's not quite as confusing. I'll feel blank. Okay, how long do you think it'll take me to drive from here to Oakland Airport on average? On average.
45.
35 minutes, 45 minutes,
35.
35, 37, 40.
How fast are you?
Right, well, yeah, it kind of depends, right? All right, so let's say 40 minutes. That seems like a reasonable answer, okay? So 40 minutes.
I don't know.
What do you think the chances are that the average, the true average time it takes to drive to Oakland Airport is exactly 40 minutes? Exactly. 40 minutes and 0 seconds. Not very likely. Right, to be exactly 40 minutes and 0 seconds. What if I did this? 40 minutes, 30 minutes, 40 minutes, add 10, 50 minutes. Between 30 and 50 minutes. Now, what's the probability that there's a bigger chance that the actual mean is, so here's 40 minutes. I'm going to minus 10, add 10. Between 30 and 50, what do you think the chances are that the actual average is between 30 and 50?
Likely.
A lot more likely. Everyone on board? What if I went further?
More likely.
20 to 60 minutes. The average.
Basically 100.
A lot more, yeah, we're more confident about that even, right? Now it's like, oh, how could it not be, really? 60, 20. So that is what we call a confidence interval. And the bigger the confidence interval, 20 to 60, the bigger the confidence interval, the more confident we are. Is that, you have any kind of following? So this is what we're talking about with these confidence intervals. Is you start with a guess, with your best guess from your sample, and then pick this interval around it. You go a certain number of standard deviations this way, and a certain number of standard deviations that way. I might go 2 standard deviations this way and 2 standard deviations that way, and then I'm quite confident it's between these two numbers. So that's kind of what we're looking at with these confidence intervals. And what we're saying is that we're not saying that there's a 95% chance that we're not 95% confident that there's not a 95% chance that the value is in this range. We're saying that we're 95% confident that this range contains the value, which is a subtle difference, but let me explain what it means, what we mean by that, really. What we mean is that, do you folks remember when we all flipped a coin 100 times on our screens, and like, I found out how many people had 41 or less heads, and there were a couple people who had 41 or less heads, and those people would write a paper because they got an unusual result, right? Like, oh, heads is not 50-50, it's really something less. It's not that heads is really less than 50%, it's that they got a weird result without knowing it. So what we're saying really is that there's a 95% chance that you don't have a weird sample, that you're not one of those weird samples that is randomly getting something strange. That's really what we say when we say 95% confidence interval. That's what we mean. There's a 95% chance that you have a typical sample and don't have a weird sample. right? So here, look at this, here's a bunch of samples. I've taken all these samples, and they caught, so say the true mean is right this black line. They fall kind of around it. And then you take your confidence interval around your sample, right? And what I'm saying is that 95% of the samples, when you take the confidence interval, they will include the mean. But every once in a while, you're going to get a weird sample out here like the one on the left that will not contain the mean. Right? So every once in a while, you're just going to get a strange sample. And you don't know, it does not contain the mean, but you don't know you've taken a strange sample. So that's what we're saying when we say 95% confident. 95% of these samples will have the mean, 5% of them will be weird, just randomly, and will not have the mean. All right, so the next thing we're going to talk about is critical values. It is a long, who can read well, very long, yep, Justin, go for it.
A standard Z-score can be used to distinguish between sample statistics that are likely to occur and those that are unlikely to occur. Such a Z-score is called a critical value. Critical values are based on the following observations. 1. Under certain conditions, the sampling distribution of sample proportions can be approximated by a normal distribution. 2. The Z-score associated with a sample proportion has a probability of
Alpha?
2
Alpha divided by 2, yep.
of falling in the right field.
Perfect, thank you.